Hi folks, this is going to be the fourth video in section 1.4. So if you'll go all the way down, we're going to talk about soap. So when we factor a sum or difference of two perfect cubes, we're going to use this acrostic called SOAP. So first of all, notice that we are adding two perfect cubes or we are subtracting two perfect cubes. Think of perfect cubes as something like 8 because that's 2 cubed, or 27 because that's 3 cubed, etc. So a perfect cube. And the way that we factor the sum or difference of two perfect cubes is that first of all, we've got plain old A plus plain old B. Notice that the plus is the same as the sign as it was originally. So that's where your S comes from, is same. The signs are the same in that first binomial. And then we're going to multiply by the trinomial. And the trinomial is going to be A squared. So whatever this plain old number was, squared, minus, okay, so this is where your O in SOAP comes from, because this is going to be the opposite sign, minus plain old number times plain old number, so that A times the B, plus, and here's where your AP comes from, and this is spelling out SOAP, plus B squared, and it's always positive because it's squaring a number. So have this handy as we work through example number 7. I'm going to have to hide it so that I can show my screen properly. All right, so you'll notice then that what I've got here is the difference of two perfect cubes. So I have an x cubed minus a 5 cubed. All right, so let's go ahead and factor. And it does say that we're using factoring, and we're going to use the quadratic formula to be able to solve. Okay, so we're, as we're factoring, we've got plain old number minus plain old number. Notice that my signs are the same. And then we have our first number squared plus, so here's where my opposite is. And then we have plain old number times plain old number. This number is always positive, and this is going to be our B squared, so that's our 5 squared. Now, to be able to solve, this is going to be solving by the zero product property, the zero factor property, which I covered in an earlier video in this same section. So let's set up two mini equations. We'll have either our x minus 5 is equal to 0 or the trinomial equals 0. So let's solve both of these. The first one's super easy to solve. The second one, we'll use the quadratic formula. So we have x equals, here's our negative b, plus or minus the square root of b squared minus 4ac, all over 2a. So we'll clean that up then. Let's clean up the square root. So my square root of a negative is going to be I. The square root of 75 can be broken down into 25 times 3. Notice at the same time, I'm sharing my common denominator. Neither one of these fractions can be reduced, but that's okay. So I have two complex solutions to that piece. But overall, I have 3 solutions. 2 of them are complex. 1 of them is real. All right. Now, some reflection here. What kind of conditions should be considered when you're deciding what method to use? If you're just given the choice of all these methods, you've got now the zero product property or the zero factor property. You also have square root method. You have completing the square, and you have the quadratic formula. So which one should you choose? So ask yourself, first of all, is it easily factorable? If it's easily factorable, this is the easiest method. Go ahead and solve by factoring. If it's not easily factorable, then the next question I would ask is your A value 1? And does it have an even B value? If your A value is 1 and it has an even B value, oh my goodness, I'm going to go ahead and use completing the square because that's going to be the easiest method. The next question you could ask yourself, is there only one variable? If there's only one variable, then I would use the square root method. If none of these occur, then my last resort is going to be the quadratic formula. Honestly, folks, the quadratic formula is the most tedious of the four methods of solving. So that's going to be my last resort for solving. All right, let's talk about solving for a specific variable. So in example 8, you're asked to solve for r. So the first thing that we're going to do, and I've already showed this here on my notes, the first thing I'm going to do is to get rid of my fraction. And the way I'll do that is I'm going to multiply by 3 on both sides. So when I multiply by 3 on both sides, I'll have 3v is equal to pi r squared times h. Now remember, what I'm trying to do here is I'm trying to isolate the r. So the next thing I'll do is let's get rid of the pi and the h. So we'll divide on both sides by pi h. And that means that the pi's are going to cancel, the h's are going to cancel, leaving me with just an r squared. The next thing I'll do is I want to get rid of that square. So I'm going to square root both sides. But remember, anytime you square root both sides, don't forget the posneg. All right, so this is what I'll have now. My r is alone, but there's a problem here. Although this is a correct solution for r, you're not allowed, a simplified answer will not have square roots in the denominator. So the next thing that you need to do is you need to get rid of that square root in the denominator. So here's how you do that. This is what you have. You're going to multiply by the square root of the denominator over the square root of the denominator. Now the value of this is just the number 1. So I haven't, it looks ugly, it doesn't look like 1, but it's just the value of 1 because the top and the bottom are exactly the same thing. Multiplying by 1 doesn't change anything. Now remember your old rules. You're allowed to multiply insides times insides. So when I multiply on top, insides times insides, I'm going to have a 3 times a v times a pi times an h all on the inside. And when I multiply the bottoms, this is the square root of pi h squared because there's 2 of them. Squares and square roots undo each other, and that leaves me with my pi h. I no longer have that square root in the denominator. For part B, what I am going to do here is I'm going to use the quadratic formula. Now, what you'll notice is that the very first thing that I did was I rearranged so that it was in my standard form. And y is my variable. I'm being asked to solve for y, so this is the variable. So I put that in red so that you could see the difference. So notice that this is, here's my a x squared minus my bx plus my c. Okay, so I do have A's, B's, and C's. My A is a 2m, my B is a negative n, and my C is a negative 3p. So I can just use the quadratic formula on this. It's a little ugly, but I can use the quadratic formula. So here we go. We've got y equals, normally we say x equals, but y is my variable. Y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's my a. So we'll clean that up as much as I can. There's not a whole lot I can do, quite frankly. On the inside, the n squared is going to stay alone. The only thing I'm going to do is here, I can take the 4 times the 2 times the 3 to give me the 24. The negative times the negative gives me the positive, and the m times the p is just standing there. On bottom, 2 times 2 is going to be 4 times m. There's nothing else I can do to clean this up. So I now have my y alone, and this is my solution for y.